Hi, and welcome to the show. I'm Chase Hyder.
And I'm Ben Pitson.
Today on the show, we will be looking at rockets and the physics behind them.
So now I'm going to give you an explanation about the physics and the forces that affect the rocket during its flight. The first one, drag, is a downward force, which is better known as air resistance. Drag refers to the forces that oppose the motion of a solid object through a fluid or gas. Drag force acts in the direction opposite to the instantaneous velocity. Unlike friction, which is nearly independent of velocity, drag forces depend on velocity. It is also related to the force of gravity down on the rocket, and that can be found by mg, g as 9.81 meters per second squared, and then the mass of the rocket. The next force is thrust or lift, and thrust is a reaction force described by Newton's third law, which for every force there is an equal and opposite reaction force.
Alright, so now that we got the basic physics principles done of a rocket, let's go out and take a test.
For the test run, you want nice weather conditions.
Here we have our water bottle rocket. It's pumped up to 80 psi and is filled with 16 ounces of water. Once Ben pulls the string, hopefully we see a rocket lift off. 3, 2, 1, lift off.
Now we're going to take a look at launch height. Launch height is in the y direction. It is measured from the launch site to the apex, also known as the highest point of the rocket. We can find this easily using trigonometry and a nifty little device that helps us find the theta. We had a preset distance of 30 meters from where I stood with the device to the rocket. And then we, after the trial, we found that it was 59 degrees. So then all we had to use was the tangent formula. So we know tangent theta is y over x. And then all we do is plug in our numbers. So tangent 59 degrees equals y over 30 meters. And then y equals 49.9284 meters. Now don't forget your sig figs. That gives us a total launch height distance of 50 meters. We also calculate the time from the apex to the time it hit the ground. Using the information that we just found of the launch height, we are now able to find the descent rate.
The equation for descent rate is v equals y over t. Y is 49.9284 meters, and then divided by t, 13.3 seconds. So velocity, being a descent, is negative, equals negative 3.75402 meters per second. But being there are 3 sig figs, take out the O2 and the 4. Get 3.75 meters per second.
Well, we hope you guys learned a lot and learned a little bit more of the physics of a rocket.
And remember, kids, don't try this at home.